As economists, some of the most important things that we do is to calculate the cost, profit, revenue, and pricing. So we need to know some very important things. So the first one is the cost function. You can write as C of x is a cost function. Secondly, we can find the marginal cost function. C prime of x, marginal cost function. Which means for an additional unit of production at level X, what is the increase of cost? Then we obviously have the revenue function, Rx equal price multiplied by quantity. Or we can say the price function multiplied by the quantity, right? P represents price. Then we can get the marginal revenue function, which is R prime X. Which is basically for an additional unit of production at level X, what is the change in revenue? We also have the profit function, which we write pi of x equals to revenue function minus cost function. And then finally we have the marginal profit function R prime x equals to pi prime x, C prime x. Okay, now knowing all this, we can move on to calculate and apply this into real life situations and calculate and do our analysis, right? So first, the company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by this function. Good. Then we want to find the marginal cost function. Marginal cost function is C prime of x because we can differentiate this function, right? 10,000 is 0, 90 minus negative 0.05 multiplied by 2 and negative 0.1 x. Yes, this is our marginal cost function. Now, we want to find the marginal cost function at the marginal cost at the production level of 500 tanks. Let me C prime of 500 tanks equals 90 minus 0.1, 500. We can calculate it, you'll get 40. Now interpret the result of part 2. What does this mean that we get 40? That means at production level 500 tanks, the cost to produce an additional tank is $40. And there you go. That's pretty simple. Now, let's move into more complex questions. A company market research department recommends the manufacture and marketing of a new headphone set for MP3 players. After suitable test marketing, the research department presents the following price-demand equation. Price x 10 minus 0.001x where X is the number of headphones, and retailers are likely to buy at price P per set. The financial department provides the cost function C of X equal to 700 plus 2X, where 700 is the fixed cost and $2 is the variable cost. Now, find and interpret the marginal cost function C of X, C prime X. Okay, we can just easily differentiate it equal to, right? This means for each additional production of headphone cost increases by $2. Find the revenue function and the function of X. So revenue, if you remember, is price multiplied by quantity. So we got the price function here, 10 minus 0.001x multiplied by x, we will get 10x minus 0.001x squared. Find the marginal revenue at x equal to 1,000, 5,000 and 7,000. Interpret the result. The marginal revenue r prime x, well, we can differentiate this function. 10 minus 0.002x at r prime 2,000, r prime 5,000, r prime 7,000. Just substitute. -4. How do we interpret this result? At production level 2000, an additional headphone produced increases the revenue by $6. And the same for 5,000 doesn't change. At 5,000 revenue doesn't change. At 7,000 revenue in fact decreases by $4 for each additional unit produced. Now let us move on to question number 4. Find the profit function as a function of x. Now we know profit is revenue function minus cost function. Right? Revenue function 10 x minus 0.001x squared minus cost function 7,000 plus 2x. We will get 8x minus 7,000. Alright, this is our profit function. Now, finally, find the marginal profit at x, 1,000, 4,000, and 6,000. Then we can differentiate this function first. We will get 8 minus 0.002x and marginal profit at 1,000, 4,000, 6,000. can just input. Alright. And here our interpretation at production level 1000, an additional headphone produced increase sales profit by $6. Then at production level, production level 4000, an additional headphone produced doesn't increase profit. Same at production level 6000, additional headphone produced in fact decreases profit by $4. Now, as a conclusion, what can we say? Conclusion. The company, if they want to maximize profit, they should produce only up to 4000 headphones. Otherwise, they will lose profit. As we can see from the graphing calculator that's more here, I have listed out each of the functions: the profit function, the revenue function, and the cost function. And here we can see that better visual intuition. The profit function, remember when we had the marginal profit at 0? Here is 4000, and at 4000 our profit is maximum. Any further increase in production more than 4000, our profit eventually falls. Same with our revenue, right? Our maximum revenue we can get is at production level 5000. After that, it continues to fall and goes below, right? And then finally we have the cost function, which is the linear function. We can see that the distance between at 4000 to a production level 4000, the distance between revenue and cost is the furthest, and there at 4000 the distance is furthest, and there we will get our higher level of profit.